5 critical events that will determine the success of the James Webb Space Telescope. The James Webb Telescope will be one of the hardest technical missions NASA will ever attempt. Despite the numerous delays, technical challenges, funding crisis, and uncertainties, the mighty James Webb Telescope was launched on December 25th. But the launch itself does not guarantee the success of James Webb. After decades of development, it all comes down to 5 critical steps that will determine whether this $10 billion project of NASA will succeed or not. What are they? Let's talk about them in detail. Every decision in astronomy and in life has its own mix of advantages and disadvantages. Setting up an observatory in orbit is costly, risky, and depends on a successful launch and deployment. There are several single points of failure, and if anything terrible goes wrong, the entire operation is a waste of time. However, if you are successful, you will be able to observe in ways that no ground-based observatory can, without interference from the atmosphere, without regard for day or night, without being affected by terrestrial light pollution, and over a range of wavelengths that are severely limited on Earth. James Webb's predecessor, Hubble Telescope, has been humanity's best optical observatory, but was limited in its infrared observations. In terms of temperature resolution, light gathering power, and wavelength range, it will be vastly outperformed by the future James Webb Space Telescope, which will greatly advance the frontiers of knowledge. Inspired from the Hubble telescope, Webb picks up from where Hubble falls short, the infrared spectrum. We all know that because of the expansion of the universe, light from the farthest galaxies is stretched to the red part of the spectrum, or infrared. James Webb is specifically made to observe these galaxies from the early universe and tell us more and more about the early universe. But whether it will safely operate or not depends upon 5 critical events. Success implies that mankind will have the most powerful space observatory ever built. Failure would result in the most expensive space garbage in history. Number 5. The Ariane 5 launch. This is obviously one of the most important events in the journey of the James Webb Telescope. It's imperative that the launch goes perfectly. Even though the Ariane 5 rocket has a solid history in launches, a launch in 2018 did go wrong. Webb will take off in an easterly direction over the Atlantic Ocean. The Ariane 5 ECA is an Arianespace-developed European heavy-lift launch vehicle for the European Space Agency. The Ariane 5 is regarded as one of the most dependable launch vehicles in the world, having launched 109 times with a 95.4% success rate since 1996. Before experiencing a partial failure in January of 2018, the rocket performed 82 straight missions without incident. The Ariane 5 rocket takes off from the European spaceport in French Guiana, a spaceport near the equator that allows the rocket to take advantage of the Earth's faster rotation speed and increase launch performance. Using an adapter known as the Système de Lancement Double Ariane, the ECA version of the Ariane 5 is capable of launching 2 huge satellites, one on top of the other, SYLDA. The adapter protects the lower satellite while also supporting the upper satellite. Its Ariane 5 rocket is regarded as a dependable workhorse, and the telescope itself has completed tests designed to simulate the conditions of a launch, so the confidence in the ride to orbit is strong. Webb will be wrapped into the RUAG space fairing at Emmen, Switzerland. This ogive-shaped fairing at the top of Ariane 5 is 5.4 meters in diameter and stands more than 17 meters tall. This structure, made of carbon fiber polymer composite, will shield Webb from thermal, acoustic, and aerodynamic stressors throughout the climb to space. Because the JWST is too large to fit within any current launch vehicle when fully inflated, it has been folded to fit inside the Ariane 5's fairings. It will unfurl piece by segment over the course of 2 weeks as it makes its way to its eventual destination. Number 4. Separation and solar array deployment. Occurring 30 minutes after the launch, deploying the solar array is another critical process. Webb must deploy vital components that were folded up to fit within its rocket when it leaves our planet and moon behind. This high-stress operation requires 178 release mechanisms, each of which must function flawlessly in order for the telescope to accomplish its 40 or so big deployments. Webb's solar power array will unfold just minutes after the spacecraft separates from its rocket and begin giving power to the spacecraft. Although the placement of a solar array is a very straightforward technique, its success is important for powering all subsequent activities. Webb's solar power array will deploy minutes after the spacecraft departs from its rocket and begin powering the ship. Although the installation of a solar array is a simple process, its success is critical for powering all future operations. The antenna is then released, and a mid-course correction, i.e. a burn, is applied, putting James Webb back on track. After barely 2 hours, the high-gain antenna is deployed and the mid-course correction confirms where it's going and how it's oriented. The antenna is fully deployed after a total of 24 hours, allowing upstream and downstream connections with the observatory. Number 3. Full sunshield deployment. After the deployment of the support structures, another very critical step is the sunshield deployment. If it fails, or if the tensioning catches or snags, the telescope will not cool, resulting in a catastrophic loss. As the telescope approaches its third day in orbit, Webb will begin to deploy one of its most complex and visible instruments, the sunshield. A stack of 5 gigantic kite-shaped sheets of polyamide film, if unspooled without a hitch, will keep sunlight and heat from reaching the telescope's infrared sensors, which must remain at extremely low cryogenic temperatures to work correctly. The sunshield is critical for keeping the telescope cool enough to detect the infrared light of cosmic dawn. However, about 150 release mechanisms must fire successfully over the period of 3 days in order to open the sunshield. Around 7,000 pieces are used in the complex deployment, which includes 400 pulleys, 8 motors, and 140 release actuators. The deployment of the sunshield is critical to realizing scientists' highest hopes for the observatory. However, the procedure's complexity and high frequency of single-point failures are the stuff of nightmares for aerospace engineers. Number 2. Mirror deployment. The anxiety of sunshield deployment will not go away soon. 6 days into the trip, the telescope's secondary mirror will be lowered into position at the end of 3 long arms. Despite its name, the secondary mirror is an important part of Webb's success, according to Hamill. If other deployments do not go as planned, there may be workarounds. The primary mirror must be deployed, resulting in a single smooth surface with 20 nanometer accuracy. Webb's 6.5 meter main mirror, composed of 8 beryllium-hewn gold-plated hexagonal pieces, will begin to unfold on the 7th day. First, 2 wings will swing out and lock into place like folding table components. The mirror segments will then be pushed or pulled into a micron-precise alignment by small actuators, resulting in the primary mirror's unique focus. Deploying and orienting the primary mirror will need the use of 132 actuators and motors, all of which must work properly. Number 1. L2 orbit insertion. The final and important event is the L2 orbit insertion. After all the 4 critical moments, it will boil down to this final event, which will determine the position of James Webb. After the first 29 days, JWST will be 1.4 million kilometers away from Earth, almost to its final destination of the L2 Lagrange point. This point is unique in that it is the sole location beyond Earth's orbit where a spacecraft may orbit and remain in the same yearly period that our planet takes to orbit the Sun. A second mid-course correction occurs, putting James Webb into its final orbit, traveling quasi-stably around the L2 point. Additional burns may be required to fine-tune the telescope's location, orientation, and orbital parameters, but there's more than a 3-month window to do so. Simultaneously, calibration and alignment of equipment in the primary mirror will commence. We'll be ready for the last pre-science stage after 4 months. The remaining 2 months will be spent aligning, testing, and integrating the components, instruments, and optics from afar while the spacecraft is cooled and in orbit. Before we can proceed, all of the instruments must be correctly calibrated. The only one ready by the end of the 4th month will be NIRCam, but the other 3, NIRSpec, the Fine Guidance Sensor, and MIRI, must be refined. When the NIRCam is finished, the telescope will experience first light, when it will collect its first science data, return its first image, and after processing, disclose it to the public. Webb's infrared vision will allow scientists to see past the dusty veil and see through it all. Webb will offer crucial information about the temperatures, speeds, and chemical compositions of black hole stellar cloaks. Scientists may use this information to understand more about the black hole's mass and size, as well as how it feeds on stars. Because the soup of the Dark Ages was not totally uniform, little regions of gas began to clump together and become more dense due to gravity. It will be similar to an orchestra concert, with hundreds of individuals playing various instruments. Everyone must have practiced their part and all instruments must be ready. And finally, the song is played. James Webb is one of the most revolutionary telescopes humanity has ever built. The kind of data and information it will tell us about our universe and what happened in the early universe is beyond imaginable. So what do you think about these critical events? How will James Webb help humanity? Let us know what you think in the comment section below. And don't forget to like the video and subscribe to the channel. It encourages us to keep on making high-quality content for you.